Hi everyone! In this video, we are going to go over the basics of statistics and probability. First of all, we are going to recall what exactly do those two words mean, because I'm pretty sure all of you have already encountered them previously. Next, we are going to go into depth as to why computer scientists have to know about statistics and probability. Finally, we are going to go over some basics and terminology that we are going to encounter during this course. I'm going to pause here for you to remember what exactly is statistics. Here we have a screenshot of an Excel spreadsheet. Here we have a bunch of data, but how can we make this more useful for us? This is where statistics come in. From the data that we have, we would like to infer some information. Here, I want you to take another pause and think about the word probability. What does that mean? Take a look at this block of color on the screen. So, in the context of a larger image, I'm only showing a small portion of it here. Would you tell me what is the probability that this block of color is depicting water in a scene? Take a moment to pause this video and determine what your answer is. After you've paused the video, what do you think? Is it a high probability that it is water, or is it a low probability? Let's confirm it. That actually was a block of water. How did you know? Next, let's take a look at this block of color. What do you think is the probability that this block of color is also depicting water in this image? Take the time to pause your video again now and think about your answer. So let's check. Apparently, the previous block of color actually was depicting water in the image. But water is not usually green, right? But how do you know that it's water? It depended on the context of the entire image and other information that you did not have previously. Just now, we were dealing with uncertainty. The block of color that I showed you could have been depicting water, and it could not have been depicting water. But in order for us to calculate how probable it was, we needed more supporting data, and it was depending on the context of the entire image. Probability is the branch of mathematics that deals with this type of uncertainty. Next, if I were to give you this statement, there is 60% chance of oil in this ocean. We could interpret this statement in two ways. The first interpretation is frequency interpretation. The reason I say this statement is because of a repetitive experimentation and repetitive experience of me checking if there is oil in this ocean. Thus, based on my data, I know that there is 60% chance. The second way to interpret this is a subjective interpretation. So in my heart, I believe deeply that there is a 60% chance of oil in this ocean. It is a personal concept to me, thus I can say this statement. In this course, the type of probability that we are dealing with is the frequency interpretation based on repetitive experimentation. You may think, but why do I have to take statistics and probability? What do you think? To put it quite simply, because we are computer scientists. These are some subdomains of computer science in which probability and statistics are very needed. Similarly, these are some applications in information systems in which statistics and probability are once again very much needed. It is not always about subjects and academics either. Probability and statistics are also very much needed in real life. Here are some samples. In pre-COVID times, before leaving the house, we would have been able to check the weather forecast for the day. The precipitation, the humidity, the temperature, all of these predictions were determined based on the history and statistics. Obviously, it is not very relevant if you are in Jakarta because it's hot every day anyway. And like for example, here in Bogor where I live, it'll probably rain regardless. But imagine if you were in a place where they had more variety of weather, this type of information that was computed based on statistics would be more useful. Okay, you've probably already heard this terminology before, machine learning. We're not going to go into that much detail, but the basics are that we are training the computer in order to learn from our data so it can become information. The underlying model of this machine learning is statistical models. We estimate some parameters of the model based on data. Such as this one, this very cool application which is able to detect and recognize objects in a video or image. This is all based on a statistical model. So I have an Android phone. So in it, I also have a Google Assistant. Google Assistant would give me the information I need when I need it based on the usual usage patterns of my phone. What information I access, what activities I usually do. So for example, in this screenshot, last year when I needed to teach the statistics and probability class, Google would give me a reminder and it would usually also give me the estimate on how long it would take for me to drive to campus and so forth. Recently, the concept of machine learning that I introduced prior has been developed into something even more able, which is using deep learning. Without going into too much in depth of what it is, let's think about what it can do. This is the Waymo self-driving car, which is able to, as you know, drive itself. Based on what it sees on the camera, it uses some statistical models and deep learning in order to identify what it's looking at and if it needs to stop, if it can avoid it, and so forth. Here is something a little bit creepy. You can check it at this URL, thispersondoesnotexist.com. The NVIDIA face generator is a deep learning model that is able to generate random faces based on the data of real faces. And using statistical and deep learning models, it's able to generate some fake faces as shown here. Furthermore, statistics and probability are extensively used for applications such as spam filtering, in which we use a statistical model to determine spam or not, and also statistical machine translation, in which we use statistical modeling to determine a translation of certain sentences. Next, I'm going to touch upon data science and big data. You've already probably heard this terminology before, perhaps via media or popular culture. But what is it exactly? So this field is very happening right now, and it's still wide and expanding, so the definition is very general. So you have science, you have analysis, and you have algorithms to interpret the data. If you recall, in the very beginning of my presentation, I said that statistics is trying to turn data into information. In data science, the amount of data we are using is a lot more. There are many different definitions out there. For example, this one describes data science as the intersection between math, statistics, and algorithms with software engineering and data communication. This source defines it as the intersection between hacking skills, math and statistics, and some substantive expertise. Meanwhile, this source describes data science as an aggregation of many things: statistics, visualization, and so on. This one combines computer science and programming with some applications, which turns into data analysis, which is supported by statistics as a branch of mathematics. So as I said before, big data basically means a lot of data, most of which these days is digital. If we have it tagged or annotated and analyzed, it will give us a lot of useful insight and knowledge. We could use this abundant amount of data to analyze political climate, or maybe to see social media trends and statistics in a certain area. Indonesian social media data is very powerful actually, as you can see here in this graph. Indonesia has a lot of content, in this case in Instagram, that can give us a lot of information if we know how to analyze and process this data. So now we want to get a better idea as to how we can achieve the previous applications discussed. Here are some basic concepts that will be covered throughout this semester in the Statistics and Probability course. If previously we already determined what statistics is for, we now divide statistics into two parts based on what we want to do. First, descriptive statistics, and second, inferential statistics. So the first one, descriptive statistics, does basically two things. It either gives us the description or presents the data. Usually we use tables or graphs. And secondly, it can give a summarization of the data. Next, after we know our data well, it is described well and presented well, we can now use this data for us to infer something. So we can draw conclusions from the data that we have. Here are some basic definitions that you will need to know during the duration of this course. Please go through your module and slides to read about these terms. So this brings us to the end of this video. Hopefully you have refreshed your memory and reactivated your pre-knowledge about statistics and probability. See you in the next video.